Good morning, good people of the SST. Welcome to the third week of eSchool. Happy Monday. Today we're going to be talking about oscillations. So, what is an oscillation? We can think about oscillation as one whole cycle. And this means the wave starts and ends in the same place while still moving in the same direction. And so we'll talk a little bit about position and direction, but let's start out with the first definition. The wave starts and ends in the same place. And so if we look at this wave, we can see that we're going to start on the beginning right here, right on our y-axis. And what we want to do is we want to look for when it ends up in the same position, right? Since we're starting at the top, the only other time it's at the top is right here over at 1. And so we can count that as one full oscillation, one full cycle, and do the same thing over here for 2, and the same thing over for 3. And so when this question asks us how many oscillations are there, we know that there are 3 total. But what happens if we start right here with the wave that starts at the beginning? We'll still start at the beginning like here, and your first thought might be to go to that point in the middle right here. But that's actually incorrect because we're not moving in the same direction. And so if we look at this red star right here, we know that our movement's going up. And if we look at our green star right here, we know our movement's going down. And so we actually need to wait until we're going all the way back up at this point right here at 6 for us to be moving in the same direction. And so rather than counting each of these as an oscillation, this one only has 2, where we go from the red to the green and from the green to the yellow. So, counting halves. There may be times when we start at the top and end at the bottom, and that's where it's really important to count halves. And so if we start at the top, we're going to measure from the top to the top. That'll be 1, 2, 3, 4, right? And then we need to count our halves. And so our halves will be in between here. So where we go from 0 to 1, this will be a half of 0.5. 1 to 2, 1.5, 2.5, 3.5. And so this gives us our final answer, which there are 4.5 oscillations because we start at the top and end at the bottom. Similarly, for this graph, we start here, we can measure our full 1, our full 2, our full 3, but then we don't have a full oscillation, right? We can't make it all the way back up to the top. And so this point right here is going to be a 3.5 because we know that it's going to end up right there. All right? So I want to just take a second for you all to practice. Go ahead and pause this video in 3, 2, 1. All right, hopefully you did that on your own, but I'm going to jump in and explain it. If we start at the middle right here, we know we're going to go full rotation right here and a full rotation right here. So that'll give us 2. After that, what we need to know is we need to know how far this is. That's going to be just 1/2. So 1/2 right there. To recap, you count from the crest to the crest to the crest, or the trough to the trough to figure out your full wavelength. If you start in the middle, you need to measure one whole oscillation by looking at them, making sure you're going in the same direction with both of them going up. Thank you, and have a good day.